Hello.
Hello. Hello.
Hello.
Hello. Hello. Hello. Okay, enough of that crap. Okay. What did you do today?
I didn't go to class. I had
Oh,
volunteering.
oh my God.
I know, but I know she introduced 6.6.
6.6. Okay. Let's try a few things from 6.6, okay? We'll jump straight to the questions and then I'll go
But I don't know anything about 6.6.
It's all about 6.5 but more information. So don't worry so much. So let's just look at 6.6, okay? So we're going to just scroll through and discuss what it was. Models. So what happens? Remember when I said a Ferris wheel and we did the Ferris
Yeah.
wheel in terms of a sine curve? That's a model using a sine curve to model the pattern of the Ferris wheel. So here's a nail. For instance, this is a water wheel and nail that's going up and down into the water. The black line represents the water. So the black line is also the x-axis, but it represents the water because that's sort of where you can kind of tell that's probably where it's going into the water. But you can also see that it's a coast curve, so you can figure out the period of this coast curve from going from peak to peak. So what level of x is this peak here?
3. I'm
At
sorry, 0.
0. And what's over here?
10.
Yeah, so what's the period? Peak to peak is always the period.
10.
Right. What's the normal period of a coast curve?
It's 1.
No, the normal period of a coast curve is 360.
Oh,
So make sure
sorry.
you know that. So here's the normal things for cos and a sine curve. Ready? Period is
Okay.
360. Write it down. Period is 360. These are the parent curves. Parent of cos and sine both have these. Max is 1. Min is -1. So therefore it has a range of -1, smaller equal to y, smaller equal to 1. That's its range. But
Mm-hmm.
it's written as max min over here, right? Okay, so far so good.
Yeah.
The amplitude is therefore 1. The axis is at y is equal to 0, not 0. Y is equal to 0. And let's see. There's 5 major points in both. Okay?
Okay.
All
Okay.
transformations affect it the same way. So I'm going to give an example. I'm just going to put a number. I'm going to make one number red, and then I'm going to go back to black. Then I'm going to make one number green, and then I'm going to go back to black. And then I'm going to make one number uh, purple, and I'm going to go back to black. And then I'm going to make the last number, and I got to close the bracket twice. And I'm going to make the last number. What's it? Yellow's kind of hard to see. Well, orange looks like that. We'll make it an ugly brown. 7. So I'm going to explain what each one does. 5. Or let's start with the 7, the brown 7. The brown 7 is the axis. Y is equal to 7. Let's look at the red. So I'm obviously doing Y transformations. Y transformations first. The 7 is the axis. The red, 5, is the new amplitude. Okay?
Okay.
Therefore, based on this information, the max is the axis plus the amplitude. In this case, 5 plus 7, which is equal to 12. So the max is 12.
Mm-hmm.
Okay? Max 12. Good enough. Min is axis minus the amplitude. So 5 minus 7. So that's the min is equal to -2. So we can see that we have a lot of information already. That's from the Y transformations. Now let's look at the color code for the other ones. What do you think the green 3 does to it?
It's the period. You have to divide 360 by
Very
3.
good. Very good. We have to divide it by 3, not multiply it by 3. Very good.
Mm-hmm.
So the 3 affects the period. Numbers where the 3 is, that's my point. Numbers where the 3 is. And I'll put the graph above that. Affects period. 360 divided by 3, which makes...
And if it was 1/3, you'd multiply 260 by
Yeah.
3.
If it was 1/3, multiply 360 by 3, it would be equal to 1080. That's right. Now, sometimes you're going to see it, and I'll just do it like this. Yeah, sorry. Hello? Hello, how are you? Now, are you going to talk to me first or to her first? Yeah, I'd rather you come see me first because I've written out the report so that I can just hand it to them. Thank you so much. Thanks. Bye-bye. So I might have to interrupt because some police officers are coming.
Oh, okay.
It's nothing major. It's just a woman in the building I want to make sure is safe. So 3 affects the period. Any number where the 3 is affects the period. You either divide it by that number, and sometimes you'll see it represented like this. Natalie? You'll just see it x over 3. And sometimes you'll see it like this. Sign 1/3 in front of the x. These are the same thing. X divided by 3 and 1/3 in front of the x. It's harder to see when it's like that. But if you look, if you look, and you look at 1/3, if 1/3 was multiplying, hang on. If 1/3 was multiplying the x, it would make x over 3. Right?
So then you'd have to...
Yeah, both are the same. These are both the same. What would I do to my period? They're both the same thing. What would I do? You set it right down here.
You would multiply the x by 3?
Yeah.
Wait, would you multiply the x or the 360?
360. The 360. And then actually all your x values, your 5 major points. So let's put that down here. I'll put the actual things you do, the x values, down below. But this is just to figure out how it affects the period. And finally, this blue 30 is a horizontal shift 30 to the right. Okay? Now let's look at each thing in terms of red. Each thing's in terms of the red and the colors. Okay? Red means 5 means multiply all y values by 5 because what you see for y is what you get. Blue, or sorry, 7, brown 7, means add 7 to all y values. And by y values, I mean your 5 major points.
Okay.
Right? Of the 5 major points.
Y values are just the 90, 180, 270.
Yeah, those are the x values. Y values are the 0, 1, 0, 1, 0, minus 1, 0.
Okay.
Right? Okay, and then 3, green 3, means, as you said, divide 3 in front of x, means divide all your x values by 3, not multiply. Okay?
Okay.
And finally, the blue 30, let's just hit enter there. There we go. The blue 30 is add 30 to all x values. So this is to the 5 major points. It doesn't matter if it's cos curve or sine curve. 5 major points. That's what you do. In this specific case, right?
Yes.
So I'm going to just copy that and send it to you. It's very...
Just if I continue writing it down.
Yeah, sure. I can do both because I have a second screen here.
Okay.
Transformation. So that means I can reverse it, right? I can figure out what number goes there to create a model. What number goes there to create a model. So I just sent it to you. Yeah, you write it down for some. I'm just going to turn down the TV so I can hear anybody at the door.
Okay.
Just for safety precaution. No, nothing, Mom. Okay, I'm back.
Okay, 1 second.
Don't worry about it. Just let me know if they get here. You got it or not? Okay.
Well, I'm in the last one. Wait, Pete, 30 means add 30 to all x values?
Minus 30. Minus 30 means add 30. Mom, please relax. Let me know when someone knocks at the door. Minus 30 means add 30 to all my x values. But you always have to do the multipliers first before you do any additions. You can't add 7 first and then multiply by 5 for y values. You cannot add 30 first and then multiply by 3 for x values. You must always do the multiplication or division first and then the additions after.
So go by BEDMAS?
No, don't think of it as BEDMAS. Just think as y transformations. I must do the multiplications first. And if you want, sure. If it helps you memorize it, BEDMAS, sure. It's not really BEDMAS because we're not distributing it or anything. Yeah. Also, remember that sometimes your teacher will be tricky. I should have sent you this instead. Sometimes your teacher will not write it like this. Sometimes your teacher might write it like this. I think you can see what's coming. And that's the only way they can get tricky with the X transformation, and that's not correct. It's the same as the one right above it, but it's not correctly factored.
Maybe that's only, you only have to factor it out when there's like a D value there, because what if it was just bracket 3x?
That's right. If it was just that, there's no factoring needed because it's just 3. And even if it was just minus 30, no factoring because there's nothing in front of X. But your teacher will always do this trick. And that's not, you might think, oh, I got to add 90 to all my X values. No. When we factor it out, when we factor the 3 out, we discover we only add 30 to all my X values. My point is that they love this trick. They love it. They're obsessed with it. You will get a question. So always look and say, wait a minute, I don't see double brackets there.
Okay.
Right? I don't see double brackets there. Okay, so just be aware, trick.
Okay.
Are you done yet?
Yes.
Okay, now the reverse is true, right? If I look at my 5, my amplitude is 5, right? That means if I have a wheel, with a radius 5, I have a wheel with the radius 5, that's where I would put the amplitude. So this, any radius of a wheel, this would go at amplitude. So radius of a wheel is amplitude 2. The axis is a little tricky. You'd have to figure out how far off the ground that axis is, or off the water, for instance. And then you have to adjust the axis. For instance, if this is a wheel that's 5 high, and the bottom 3 meters is underwater. The bottom 3 meters is underwater. Where's the axis? If the bottom 3 meters is underwater, where's the axis? If the bottom 3, if this wheel is 5 radius, and the bottom 3 meters is underwater, what is my axis on a Cartesian graph? It's a good question. If this wheel has 3 meters underwater, what is the axis?
Wait.
So what
is axis? Like,
axis is right here. Cuts the wheel right in the middle.
So what's the axis of the entire wheel, or
what would you see in the formula? What would you see in the formula? We know with the 5 we would see this. We know with the 5 we would see something like this. Y is equal to 5 sine x, or y is equal to 5 cos x. We're not sure what yet. What?
Oh, is underwater like negative?
Underwater is considered below the x-axis, yes.
Okay, so it would be 2?
Yeah. The axis in this case would be y is equal to 2. So you have to sometimes figure out where the axis is compared to the question. And whatever it's underwater, that's always considered the x-axis. So you're right. That means my max values are
7.
Yeah, and min.
And your min?
Yeah.
Min is going to be -3.
2 minus 5, negative 3.
Oh wait.
Yeah, no, you got it.
Okay.
Minus 3. There you go. So you can see once you figure out the axis, and if you know the amplitude, you can figure out that. Sometimes they don't give you the axis, and you only know the max value and the amplitude. So there's all sorts of things that tricks. So if you know, for instance, okay, so you got all that, I'm going to just send it to you fresh.
Yes.
Okay. By the way, if this wheel goes around in 10 seconds, I have to change the period, right?
Yes.
If this wheel goes around in 360 seconds, I don't have to change the period. Okay. So I'm going to just send this to you again. All right. So now let's look at some models. And that's the best way to do it, is just to go to some problems. We'll go with this one. A nail is located in the circumference of a water wheel, which is moving and the current pushes the wheel. Notice they only give us the graph. They don't give us the formula. So obviously they want us to come up with the formula, right? So what are some things we can look at right away, like period, amplitude, stuff like that? And how would we look at it? Where would we find it?
So we know that the amplitude is 3
How do you know that?
because the peak reaches 3,
But what's the lowest point?
-1.
All right, so here's the formula for the axis.
Oh,
Ready? Max
yes.
plus min divided by 2. So max plus min first, and then divided by 2 is equal to axis. So why don't you add those things for me?
3 plus -1 is 2.
Okay. So we got 2.
Divided by 2 is 1.
So the axis is y is equal to 1. Let's see if that looks right. So we're going to locate y is equal to 1, and we're going to draw a big red line through it. There's y is equal to 1. Now, does that look like the axis of the curve?
Yes.
Yeah, whereas this does not. And this does,
Yeah.
and this does not. So you can almost visually see that, yeah, that's the axis. Okay, but this is a formula that you should use.
Yes.
Here's another formula that you can use. Max minus amplitude equals axis.
So 3 minus...
Well, we don't know the amplitude, but let's instead look at a formula for amplitude. Amplitude is either equal to max minus min divided by 2, or amplitude is equal to max minus the axis. Either one works. Depends what information you have. We have both, really, because we figured out max and min, didn't? Or we haven't figured out max and min. Since both include max, why don't we figure out what the max of this is? What's
the max is 3?
The max is 3. What's the min?
-1.
Right. So we have a lot of information. You can use either formula. Which do you want to use? Max minus axis? The axis is what is 1.
Yes.
Okay, so if we're going to use the second one, the max is 3. The axis is 1.
So 3 minus 1 is 2.
So the amplitude is 2.
Oh.
And visually we can see it right here, right? Because here's the axis, and if I go up, I can see I go from 1 to 3. So that means my amplitude is 2.
Okay.
Right? So I'll just mark it.
Yes.
Great. We have a lot of information. Don't we have the axis already?
Yes.
Okay. Don't we have the amplitude?
Yes.
Okay. So amplitude and axis are both y transformations. So let's write them here. We don't know if we're dealing with a cos curve. What do you think we're dealing with? If we look at it carefully, we can see it starts here, goes down, and then goes up. What does it look like?
Cos curve?
Yeah, so we're probably dealing with a cos curve, since especially it starts at the top. What did you determine the amplitude was?
2.
Right? What did you determine the axis was? It's right here.
3.
Nope.
Sorry, it was
No.
1.
It's yeah. So where would they go here?
Amplitude would go in front of cos.
Yep.
And then the 1 will be plus the x.
Plus 1. No. These are
Not the x, but I meant bracket.
Outside the bracket. Everything away from x is a y transformation. Everything outside the bracket of x is a y transformation. That's another good way to think of it. Anything outside the bracket in here, these are brackets right here, Anything outside of there is a y transformation. Good?
Okay. Okay.
Okay, now we got to figure out the x transformations. X transformations are period and phase shifts. X transformations are period and phase shift. Okay, the normal period is 360. So now before we do period, does this cos curve look like it's been pushed left or right?
Mm,
Doesn't it start at the peak here? Doesn't it start
yes.
at the peak, go down, and then return to the peak?
Yes.
So it
So
looks
now.
like it has not been transformed horizontally. So we would make a note
Okay.
because it looks exactly like a cos curve. It looks like no horizontal transition left or right. Good.
Okay.
All right.
Yes.
So that means we only have to worry about period. You already figured out the period. The period goes from peak to peak. What did you tell me the period was?
10.
Right. What's the normal period?
1.
No.
No, sorry. 360.
Say it
My
three
gosh,
times
I'm like
fast. Period is
20.
360. Period is
No
360.
more period is D60. No more period is D60. No more period is D60.
Good. What do I divide? What do I divide 360 by to get 10?
36.
Yeah, so it looks like 36 is my magic number. But what do I do? Do I do x over 36 or do I do 36x? Hmm.
You do 36x
Why?
because you're dividing 360 by 36.
That's right. So now we figured out the entire graph of this model. And that's what this
If it
is.
was x over 36, you'd be multiplying 36 over
That's right.
360.
That would make the period huge, a very slow water wheel. Let's see if we got it right. Let's see if what's the best way to see if we got it right?
Desmos?
Desmos! The first thing I got to do is change the period from radians to degrees. Otherwise, it won't work out for us. So now I'm going to do y is equal to 2 cos, open brackets, 36x plus 1. And now we're going to see, it doesn't look like our graph because we didn't really squish it the way, but we should just see if the period is 10 seconds long. Here's the beginning. Here's the end. Is that period 10 seconds long?
Yes.
Okay, let's see if our max is 3 and our min is -1. Let's
Yes.
see if our axis is at 1. What would I type in for an axis at 1?
You would type in y equals 1.
Very good. And there, it looks like it's right in the middle of that curve, doesn't it?
Yes.
I think we got it.
Yes.
All right.
See, what I'm afraid of is that, like, in the test,
Yeah.
it'll be, like, tricky and, like,
Yep.
I won't know if it's, like, cosine or sine. Because what if, like, the cosine is, like, reflected and, like, shifted
I
and,
got
like,
news for you, hon. That's part of life.
but is there any way I could, like, figure it out, like,
Not
be
easily.
sure?
No, it's just practice, honestly. So let's look at the sine curve, right? And
Mhm.
I'm just gonna pretend my Ferris wheel takes 360 degrees to go around. That'll make it a lot easier on us. Okay, so I'm just gonna pretend we're not changing the period here. Okay, and I just got to change this so it looks more like a sine curve. There we go. And let's pretend I just show one revolution of the equals x smaller equal 360. There, I've just shown one cycle of my Ferris wheel.
Okay.
If the x-axis is the ground, right here, what is wrong with my Ferris wheel? If the purple line is the ground, what is wrong with my Ferris wheel?
It's on the ground broken.
Yeah, it's going under the ground, which would be a
Yes.
really cool Ferris wheel if they put. I always thought they should put like a haunted house in the bottom
Yeah.
half of a Ferris wheel. I think that would be awesome. And nobody's done it. Natalie, let's make millions. Okay, anyway, you're right. What now? Let's look at the normal amplitude. What's the normal amplitude of a sine curve?
It's 1.
Yeah, so its max is 1 and its min is -1. How do I get this Ferris wheel off the ground?
you're gonna add uh one.
Where?
No, add sorry two. Add two.
Yeah, let's add 2 to get. If I add 1, it's touching the ground, which is okay.
Yes.
Kind of weird. A lot of scraping sound. So, but instead, we're
Mhm.
just going to add 2 and get it right off the ground. Now I've got to climb a ladder to get on this weird Ferris wheel. I've got to climb a 1 meter ladder. So if you want, let's cheat a bit and pretend it barely touches the ground that you can get on. Now, what's wrong with my Ferris wheel? Isn't this the start of my Ferris wheel?
Yes.
Isn't that the bottom of my Ferris wheel?
Yes.
Don't we normally get on the bottom?
Yes.
How far out of sync is my bottom?
About 1 meter.
Well, out of sync, or let's phrase it differently. How would I get that bottom to start over here? How would I get that bottom to start over here?
You have to phase shift.
Yeah. How much phase shift is it out right now? You'd look at your X value.
It's 270.
So how would I get a 270 to the left?
You would have to subtract 270.
Oh, Nelly,
Oh,
that's
sorry. Add
there you
add
go. Let's
270.
see if you got it. Oh, look at that. You got your Ferris wheel to start at the ground. Oh,
Hmm.
now 270 seems like a lot. How much in 360? How much is three? How far away from 360 is 270?
It's 90.
What happens if I phase shift at 90 to the right instead? Let's have a look. Oh, it's there as well.
Oh.
Why is that? Because over here I put the period restricted. Let's get rid of the period restricted. We can see that under the normal sine curve, the bottom is also to the left over here. The bottom is also to the left over here, 90 degrees away. It might be easier for me to phase shift it to the right, 90, than 270
Oh.
to the left. Ah, we're starting to all put this stuff together. But wait a minute. I hate phase shifts. What happens if I use a coast curve instead? Okay. This Ferris wheel starts at the top. I don't want it to start at the top. How would I get that top to the bottom? There's two
You have
different ways. There's two different ways. Yeah.
so one you can
Here's the
um
bottom over here.
180.
Yeah, I could move it 180 to the left, or guess what? 180 to the right also works. But I just
Oh.
didn't, I don't like phase shifts. I just said that. Maybe there's another way to get that top to the bottom.
You can.
Remember that this is the axis here now. How maybe that axis looks like a mirror. Mirrors have reflections.
So you can um change the amplitude to negative
Yeah, the amplitude to -1. So I just put a
one.
negative in front. Let's see if you got it. Look at that. My coast curve starts at the bottom. I don't have any of those awful horizontal phase shifts that I hate figuring out. And all I had to do was reflect it. That
Oh.
means I have to multiply all my y values by -1 and then add 1 for the axis. And I don't have to do
Can
anything.
you
I don't have to do anything to my x-axis. Can I do what?
can you show two full cycles?
Sure. You just make this to what? What do you think you do that? What do you
To 720.
You got it.
Oh, okay.
And if the Ferris wheel goes around 3 times, you got to add 3 cycles. Depends how many times they tell you the Ferris wheel goes around.
Okay.
Notice it hits the max height here, but it also hits the max height here 1 period later, the max height here 1 period later. A lot of questions ask you how many times does and what time does it hit the max period. All right, let's move on to better examples. It's a good idea to play with your Desmos because the Desmos will really help you understand it faster. Ferris wheel example. Faster than anything else. Playing with things. Here's a good thing, Natalie, because numbers and books and reading is kind of boring. A lot of people who go into engineering because they like making things. They like making crossbows and catapults and armor, and they like making things. Sometimes playing with something that's visual, like Desmos, is a lot easier. So they're just going through how they calculate this water wheel. And now we're going to do a different a different question. We're going to say, okay, well, that's, yeah. Now, I don't, so sometimes I hope your teacher doesn't give you a chart. Sometimes you got to look at a chart and say, okay, this thing's reflecting the moon, and it's kind of annoying, kind of annoying. So
Mm.
one thing you can do with charts is you can say, okay, looking at the numbers, we can see that there's a numerical thing, and it's days of the year. So these are days. So they're going by every 3 days. And
Okay.
let's look at what happened to the moon visible. 0 of the moon's visible, and then 100% of the moon visible, and then it goes down again to 0, and then it goes up again to 1, then it goes down again to 0, and then up again to 1. So it looks like the min value, looks like the min value, the lowest value I see on my y-axis here is 0, and the biggest value I see is 1.
Mm.
What's the axis? If the max is 1 and the min is 0, what's the axis?
0.5.
Yeah, beautiful. So maybe we'll go to decimals, and we'll say y is equal to sine 0.5. We'll just do start there. Oh no, this one goes down to -5 and to 0.5.
Mm.
Looks like my axis, looks like I have the right amplitude, half up, half down, but my axis is, my min's wrong. My min should be at 0, and it's at -0.5. What can I add to my y values to get this -0.5 up to 0?
But you could plus 0.5.
Well, let's see if that helps. Oh, look at that. My max now is 1, and my min is 0. So far, so good.
Mm.
I think we've solved our y values easily here. So now let's look at our x values. We're going to go back. And we're going to say, okay, my x values go to 1, all the way from 1 to 74. What's my period? 1 to 74.
It's 74.
Yeah. So wouldn't I have to take my 360 and get rid of it by dividing by 360? That would bring it down to 1. And then multiply it by 74. So I'll do that again
Mm.
for you. If I take my period, if my period's 360 and I divide by 360, what do I have as a period?
1.
1. If I want to turn that 1 to 74, I should multiply it by 74.
Yes.
Okay, so that means I have to divide my period by 360 and multiply it by 74. What would I put in front of x if I want to divide it?
Oh, wait. That
Yeah,
makes a lot of sense
yeah,
because I had a question. One of the questions that you gave me, I was like, this is not right. Because it was like told me that the period was 720,
yeah.
and then I assumed I just had to multiply 360 by 720, but no.
You're right.
And
Instead,
the number was large.
you'd have to put 0.5 to make 360 by 27, or that's the same as 1 over 2. So when I have 1 over 2 like that, instead of multiplying my 360, sorry, instead of dividing my 360 by 2, that makes me multiply my 360 by 2. Let's look at the period of this. So I'm going to just, it's a sine curve, right? So it's sort of out of phase because this x has to be in brackets. Let's see if it does it. No, why is it out of phase here? I think because why? Why does this not start at the bottom? It's period. Do I have to put a half here? No. For some reason it thinks, oh, I think because, let's see if we get rid of that. There we go. For some reason it thinks that's being added to x. Why is that being added to x? Let's start here and do it like this. 0.5 x, close, plus 1. No, it's still screwing it up. For some reason it's not recognizing the closure of this bracket here. Let's try it this way. 0.5, 0.5x plus 1, or plus 0.5. There, no, it's still, why is it starting? It shouldn't be starting here. This should be, oh yeah, no, I'm wrong. There we go. That's the proper sine curve. Now, what's the period from here to here? What's my period?
720.
Right, so that 0.5, which is 1 over 2, created the 720. The 2,
Ooh.
a 2 actually creates a period of what?
of
180.
80. Wait,
Right.
Pete, but how did you know that?
Well, because
Oh
I've been
wait,
doing
because
this
you
for
had some.
5,000 years.
Okay, that makes sense because it had to be 1/2 because 1/2 would then um
M-
multiply 360
Instead
by
of
2.
dividing it by
Okay.
half. Now let's hang on. Didn't you tell me that the sine curve is 360? Sine curve is 360. How
Yes.
would I turn that into 1 again?
Divide by
What
360.
do I put in front of x to divide 360? Do I put 1 over
Uh,
360 or do I put 360?
you put 360.
Yep. So now, it's hard to see it, but now I want to turn my period into 74. I brought it down to 1 with that 360. How do I turn it into 74?
You multiply by 74.
Oh, that doesn't make sense. So I've multiplied it by 360 and multiplied it by 74, but 1 is
Oh, you
dividing.
divide by 74.
Oh, so it looks like this fraction here creates a period of 74.
Yes.
Right. So it looks like all I have to do is put 360 over the period I want to create the period I want.
Hmm.
Oh,
Okay.
memorize that. Looks like I just have to put 360 as a fraction over the period I want. So in other words, it would be this. 360 over period I want times x.
So that would work with
It'll
360
work with
over
anything.
720?
It'll work with anything. Yeah, sure it will. Yeah, because the 360 turns it into 1 and the 720 turns it into 720.
Oh, so that could be in my equation?
Sure. But of course
In the
your teacher wouldn't want to see it like this because it's not a simplified fraction. This 360 goes into 360 once and it goes into 720 twice.
Oh, okay.
It's the same fraction. It's the same fraction. Just the teachers don't like this because it's an unnecessary big number. However, this instantly is a great way of creating the period you want. 360 over the period I want.
Okay.
Write that
But you
down.
said to simplify it after.
Yeah, just simplify it after though. You can instantly come up with the period you want by doing 360 over the period I want and then simplifying it.
So what about 360 over 74?
Sure. Let's go check out our period and see if it works. Okay, so here's the beginning. Okay, here's the beginning of my sine curve. Let's see if it ends at 74. So one of the problems is I don't have a nice line in there like the axis. So there we go. Now I can click on that little dot. Oh, oh, oh. So name a period you want there, Natalie. Name
74?
no name a different period you'd want.
Oh, well, no, but Pete, how would you simplify 360 over
Oh, good
74?
question. Looks like they both end in a 0 and a 4. Both can be divided by 2. So this is 180. And this is 35 plus 2, 37. I do not believe they can be simplified anymore. 37 doesn't have many things that divide into it.
So I
Done.
wouldn't get marks off for doing that?
No, why?
Just because you said she doesn't like to see it like that.
Well, just don't leave it like that. Start with that and then simplify it. It's so much faster. So much
Okay.
faster. Name a period you want. Name a period you want. Any period at all.
360 over, wait, let me,
Just name a period.
1080?
Okay. Let's go see if it starts at 0. Let's see if it ends at 1080. Ooh.
Yes.
Yeah. Name a period that's smaller than 360.
So wait, Pete, that would be 1 over 3x.
So right away, we can divide both by 0. Looks like I can divide this by 3. I get, well, hang on. They can both be divided by 2 again. 15, 18 over 54. Looks like they can be divided by I think both by 9. 2 and 8, I think. 8 times 9. And then you write 1 over 4.
Huh.
It's the same fraction. It's just simplified. I don't know if that's what we wanted, 21/6. Okay, but let's use our technique again. Name a period you want.
No, Pete, that's incorrect.
Okay, I did a division wrong,
It's 1
Natalie.
over 3.
Okay,
P is 1 over 3.
thank you, Natalie. There, you
Yes.
get to go.
That's what I need to know, Peter.
Well,
That's
no,
what I
you can
needed
do it
to
on
know.
your own time. I'm not here to do the minutia. Name the period you want, though. Let's use this technique. Name a small period you want. A small one.
Uh, 9.
9. Woohoo! So let's do it this way instead. I'm going to go from 0 to 9. And then I'm going to go to my axis and see if we got it. You get it?
Yes.
Oh, what a simple way. Now all I have to do is divide 9 into 360, and it goes 40 times. I could
Okay.
just even maybe use my calculator. 360 over the period I want is such a good tool that every student should know, and nobody does. So screw them all,
Okay.
right? It's a great,
Yes.
it's a great tool. So back to this.
Great.
We've made the period we want, 74. But does my thing start at the bottom, the min value here, or at the top? Do we start at the bottom here or at the top? What's my max? 1. What's my min?
0.
0. This looks like it's a little bit to the right of 0. How much more to the right of 0 is it?
0.02.
So it looks like I should phase shift at 0.02 to the right after I get the period right, right?
Yes.
Okay, so I'm going to do 360 over the period I want, 360 over 74, and then I'm going to just change this again so that we can see it. All right. And then I'm going to phase shift it. So I got to put my X in brackets in its own bracket, otherwise it doesn't phase shift it correctly. And I'm going to put negative 0.02 to phase shift it to the right, 0.2. And let's see if we start at 0.2 here. Ooh, look at that. But
Oh,
wait a minute,
okay.
we're in the middle. We're in the middle. We wanted to be at the bottom. We wanted to be over here. So we phase shifted it incorrectly. So let's see where we would phase shift it. Okay, looks like the bottom is way over here. So it's
Hmm.
harder to figure out where the bottom is, right? It's harder to figure out where the bottom is. So maybe we should use a coast curve instead.
Is it because you put half?
Yeah, but maybe we should use a coast curve. Look, that's at the top, isn't it? How would I get that to
Yes.
the bottom?
You'd have to phase shift it
No,
1.
bottom. It looks like that purple line is a mirror that's reflected in it. If I want to go all the way down to the bottom,
You have to minus.
yeah, right here. Let's see what happens. Whoops. Oh, look at that. It's at the bottom, but it's not at 0.02. It's at 0. How would I get it to 0.02? Now I can subtract 0.02. And now look at that. I start at the, well, there we go. I start at the bottom at 0.02. And now I can even see if my 18.5 matches 0.5 on the graph. 18.5 matches 5. At 18 is around here. No, I'm hitting max value there. So it's not always going to be exact, right? So we have to fiddle. No, no, no. The point is that this is not an accurate, this is just some stuff
Right.
some guy observed through a telescope. So if we had
Yes.
an accurate, if these numbers were bang on, we can use these numbers exactly in the formula. But because the moon, these numbers are clearly all over the map. So we probably shouldn't even phase shift it. We should probably just make sure we're at the max at day 14 and leave it at that. So,
Okay.
and we're not. So, obviously the numbers aren't quite where I want them to be, but you're never going to get a perfect model when it's not when it's not an accurate system. Okay. Now, let us go back to the book and find another model to base it on. I don't like graph numbers for models because it's harder to see, but they walk you through it. Let's take some actual questions. So notice that they do give you some numbers. You should probably practice those because visually they're harder to see.
Okay.
But we should, yeah, actually they all like that. So maybe let's take, that's a hard one. Let's take the cold months of Ontario right here, the cold months of Ontario. So it would be good to figure out what the min and the max is. And so when given tables, it's good to figure out min, max, and axis.
So the
When
minimum is negative 18.6
yeah.
and the maximum is 17.
So give me a formula for axis that you've already learned. What's a formula for axis? Axis is equal to
Axis equals max minus min divided by 2.
No, I think it's max. Don't you have it written down?
Yes. It's um oh yeah, wait for access?
Axis, yeah, we've done it. I sent it to you.
Yes, I have it written down. Just like a lot of notes.
Yeah, I know that's the problem. So that's why studying and practicing is better because all these notes are hard to regurgitate.
Yes, it's max plus min divided by
Okay,
2.
so max plus min or min plus max doesn't matter, divided by 2. You told me the min is minus 18.6 and the max is 17. What happens when you add those?
It's gonna be negative 1.6
Negative 1.6 divided by 2
is negative 0.8.
Okay, give me a formula for axis. Give me a formula for axis. Or sorry, that is the axis, right? So if I was going to do a sine curve, I would put my axis right here. Right? Out here.
Yes.
Give me a formula for amplitude.
It's gonna be max minus min divided by 2.
Ah, so amplitude is similar. Max minus min divided by 2. The max is 17 minus the min minus 18.6. What's my 17 minus 18.6?
It's gonna be 35.6.
And then you got to divide that by 2. So break open the old calculator.
17.8.
Right. So you figured out the amplitude. Can you tell me some numbers I would write into a formula with just these axes?
It would be 17.8 sine.
So we'll just do, yeah, we'll just do it like that. 17.8 doesn't, we'll leave it sine for now until we figure it out some more. Then what else can I
Okay.
put?
Plus, subtract 0.8.
Right. Okay, good. Now, in looking at these months, how many months are there in a year?
12.
So what's a period? If the period's 12, what would I put? Don't simplify it. What would be a good number to put in front of X if I want my period to be 12? Remember I said something divided by something.
360 divided by 12.
Right. Now we'll simplify it. Why don't you take your calculator and see if 360 divides by 12?
30.
Right. So that should create a period of 12. Now, doesn't January start at the lowest value?
Yes.
So that means my curve starts on my graph at the lowest value, goes up and then comes down. Makes sense because summer, which would fall here, is going to be the hottest month, and January and December, which fall there, will be the coldest months. But what curve starts at the bottom? I don't have any. I have cos curve that starts at the top. I've got sine curve that starts in the middle and goes up. How can I get a curve easily that starts at the bottom? Hint.
Do you reflect it?
Yeah, hint, take the cos curve that starts at the top and reflect it. How do I reflect it? Where would I put the minus here?
In minus 17.8.
Right. Let's see if we got it. So it looks like we should use our formulas when we're using a table. Find your axis and your amplitude first from your table. And then you're going to have to logically, period, then period, do 360, divide the period you want. And then you're going to have to logically figure out where it starts and where it goes. Okay, let's see if we got it. Y is equal to, what did we put in front? Negative a 17.8, 30x minus 0.8. Negative 17.8, open bracket, sine, open brackets, 30x, close, minus 0.8. Now my period is 12 long, so to see it on the graph, I have to go here and make my axis go from 0 to 12. My max and my min, you told me my min goes down as low as minus 19 or so and up as high as 20, let's say. And now we've got to go back and kind of figure out why my thing isn't showing it very well. And we got to go say, okay, let us go from, did I lower it? Wasn't I supposed to raise my axis? No, I was supposed to lower it. Okay, now I want to, I think this is just Desmos getting confused. So I'm going to, because of this here. So let's just get rid of that. Let me make sure. Oh, I know. I'm not in degrees. Bad. There we go. So it's a cos curve, though. I don't want a sine curve. Cos curve. And I want to... There we go. Now, we're going to see if it starts at the bottom. And actually, let's just restrict our period, our domain, to the first 12 months. Smaller equal to x, smaller equal to 12. All right, here's my thing. Let's make each unit steps of 1 so we can see each month. Here's the coldest month, January. I got the start. Can you tell me what it says in the box? Oh, I guess you can't. Let's see if we got the max. This is June 17. We're not going to get, it's not going to be perfect. Oh, yeah, it is pretty good. Oh, June's over here. So they got July 17. The reason it's not perfect is because weather does not follow a perfect curve. It will suddenly go up a lot and go down a little bit, but it's the best we can do. We want to see if we end roughly around the same area. And you will never really be able to reflect nature perfectly. But essentially, we start cold, we get up hot, we go down cold again. So that's fine. Let's figure if we got March right. March says it should be 0 degrees, and roughly September should be 0 degrees. Okay, March is a bit below 0, and September's a bit above. It's okay. We could probably phase shift it a little bit this way or a little bit that way and get it bang on. But whatever.
Okay.
Yeah, this is good enough. Yeah?
Whenever you're doing 360 over the period I want, to simplify, would I just put in front of x the answer that I get when
Yep.
dividing 360?
Yeah, but
Even
just
if it's decimal?
No, you don't want to use decimals. Your teacher wants to see a fraction. So the easiest thing to do is see if you can divide both numbers by 2. So 360 divided by 12. Can 12 be divided by 2?
Yes.
Can 360 be divided by 2?
Yes.
Okay. Can 180 be divided by 2?
Yes.
Okay. Can 6 be divided by 2?
Yes.
Can 3 be divided by 3?
Yes.
Can 90 be divided by 3?
Yes.
There.
30.
So I didn't need a calculator. I just had to kind of go slow.
But what if it was like 13?
Yeah, well, then you're screwed because 13 is not dividable. So if you want a period of 13, you're done. That's it. 360 over 13 because 13's only divisions are 13 and 1. It's a prime number.
Okay.
If you got a prime number down here, you're done. 360 over 13, boom, we got it. Let's see if we go all the way to 13 with that. You might say, I see it only going to 12. But remember, I restricted my domain to 12, so 13, sure enough, look at that, we end at 13. So
Okay.
if ever they add an extra month, you know what to do.
Okay. Okay.
But that's the best we can simplify it. And your teacher does not want to see this. Your teacher does not want to see this. Even though it's the same number pretty much, we would never see that in front of x.
Okay.
We would see the fraction. And how easy is that? 360 over the period I want.
Yes, that's very easy.
Yeah, just remember the phase shifting takes some thinking. Where's the bottom? How do I get my graph at the bottom? Especially when a sine curve always starts, a sine curve, I'm going to get rid of the reflection. Sine curve always starts in the middle. So things that start at the bottom or the top, usually a cos curve is better.
Okay.
Right? Because cos curve starts at the top, and if I reflect it, it starts at the bottom.
And then the sine starts in the middle.
Yeah, if I have something that starts in the middle, but I can't think of many things that start in the middle. Usually I have to phase shift my sine curve. So I can make my sine curve start at the bottom, because the bottom of my sine curve is over here at 9.75. It's just hard. Well, let's put it back to 12. It's down here at 9. So that means I would have to phase it left 9, I would have to add 9. I gotta go x minus 9. But the problem is it's hard to figure out. Oh, now it's at the top, so I actually phased it the wrong way. So it should be actually phased, because I was supposed to go plus 9. There we go. Now my sine curve starts at the bottom. But the problem is it's hard to know that 9 is at the bottom with the new period unless I do the transformation of the 5 major points. Oof. It's easier just to understand cos starts at the top, ends at the bottom.
Okay.
right? Or cos curve starts at the top. If I reflect it, it starts at the bottom. Okay,
Okay.
let's take another example here, because these models really, it looks like they're giving us tables like crazy, and these are very. Oh, I like. No, that's a hard one. So that's in the extending. Whenever you see extending, very hard. Let's take another one. Oh, she's breathing. Who cares? Okay, let's just try to answer 6, because
Wow.
she will give you something like 6. So we're going to just focus at one thing at a time. These are 4 different curves. So we want to see what we would put as a formula to achieve those
Okay.
results. And we're only looking at the cosine function. See, use a cosine function.
Yes. Okay, so it's gonna be 3
Mm-hmm.
cos.
Okay.
Um. Bracket x.
Yeah.
Uh. Plus 11.
Yeah, because there's no horizontal translation or change in the period. So that is correct.
Yes.
Now the next one, B.
Um.
That's this one
4
here.
cos.
Yeah. Y is equal to 4 cos. Yeah. The reason I put the Y
Is
is
equal for
because there's a
cos.
result that's Y that we're going to need later on. 4 cos. Yeah. What happened to the period?
Um.
I want my period to be?
It got 180, so it's gonna be 2x.
Yeah. 360 over the period I want. It's clear that that's 2x.
Yes. Plus 2x. Actually, do you want me to factor?
So up to you. It's up to you.
Okay. Bracket 2 bracket x minus 30.
Yeah, because they just say 30, which means plus 30. Good. And then
Bracket plus 15.
you got it. Do the next one.
2 cos.
Yeah. Now let's just use my trick for the period. 360. What's the period we want?
40.
Right. I notice they both end in 0. Can I just get rid of the 0?
Yes.
What's 36
36
divided by 4?
It's 9.
Yeah. That was easy enough.
Yes.
Okay.
9x. X minus 7.
Yeah.
And no equation axis.
That's right. So it just disappears. It's technically plus 0, but it's invisible. Okay, next one.
Okay. Y equals 0.5 cos.
Yeah, usually they do a half. Usually we don't like 0.5 in there. But that's okay. Whatever your teacher prefers. Here's my period.
Bracket 1 over 2.
Yeah, and here's the period I want. So we're talking 1 over 2, which sometimes might 1 over 2, which sometimes might be x over 2 if there's no phase shift. But I think there's a phase shift. So
Okay.
you're gonna have to say it again.
Okay, so 1 over 2.
Yeah.
Sorry, 1 over 2 bracket x plus 56.
Yeah.
Minus 3.
You got it. And that's how you, based on information, that's how you construct it. This trick is very good.
Okay.
360
Very good.
over the period I want. 360 over the period I want, and then just simplify. Okay? Now, Natalie, she's going to have another chapter coming up, and the next chapter is solving problems, which is a lot harder. I want you to look at this. I'm going to just do one with you and then let you go, okay?
Okay.
Let's stay in there. I'm going to construct a Ferris wheel. I'm going to use f of x. And I'm going to make my Ferris wheel, it's going to be a 15-meter diameter. And I'm going to get to where it starts in a second. But it's going to start, since it's a 15-meter radius, right? Because the amplitude is the radius of my Ferris wheel. That means it's 30 diameter.
Yes.
Right? 30 diameter if my radius is 15. And I want my Ferris wheel to start 2 meters off the ground. Or 1 meter off the ground. what would I put as a, if I want a 15 radius Ferris wheel, therefore its diameter is 30, and I want it to be 1 meter off the ground, what would I put as the axis number at the end here?
The axis number is going to be 16.
Yeah,
16.
very good. That's the amplitude plus 1. Now, if I look at this, and okay, now I want my Ferris wheel to last 60 seconds. What's my normal period of my Ferris wheel?
360.
Yeah. So, and what's the period I want? I told you 60 seconds, right?
60.
So that's what I want. Can I get rid of the zeros?
Yes.
Okay. I don't think they can both be divided by 6. Oh yeah, they can. 36 divided by 6 is?
Is 6.
Yep. So that should create a Ferris wheel that has a 60-second period. Now, I've used a coast curve. Now let me just visually get it right. So I want to go all the way from the ground, 0, to the top of the Ferris wheel, 31. And I want to see the first 60 seconds, 0 to 60. There we go. And there we go. Now I'm going to make it one period. 0 smaller equal to x smaller equal 60. Okay, the only problem is I want my Ferris wheel to start at the bottom of the ground. This Ferris wheel looks like it starts at the top.
So you have to
Say it again? Can't hear you. Say again?
You have to reflect it?
Yeah.
Reflect it?
Yep.
Subtract?
Yep. Got it.
Okay.
Okay, now here's my question. That was my question. I'm going to show you something. I'm going to show you a value of A. This is just a line. A is equal to 1. So, or actually, let's do Y is equal to 1. There we go. That's the bottom of my Ferris wheel, isn't it?
Yes.
Now I'm going to go make this line go all the way from 1 to the top of my Ferris wheel. My top of my Ferris wheel is 31. 31, right there. So I'm going to make this line go all the way up to 31, and I'm going to tell it to move it like this. And then I'm going to hit play. Look at this line.
Yes.
Okay. How many times does it hit my graph? How many times does this black line go through the graph?
30 times.
No. How many times does the black line cross the green line?
Oh, twice.
Yeah, except here, where it only crosses it.
Except
Where it only crosses it, how many times?
once.
At the top. So it looks like every spot it will cross it twice except the spot at the top. Keep in mind that for a sine curve, there's an extra value, a sine curve. It only crosses the top once, the bottom once. Every other spot is twice, except at the axis, it touches 3 times.
Yes.
So keep that in mind. Sine curve is twice, except at the top and bottom it's once, and at the axis 3 times. Slightly different than the coast curve, which only touches twice, which is except at the top where it touches once. That means at this Ferris wheel, doesn't the y-axis represent the height of the Ferris wheel? It goes from 1 to 31. Isn't that the height of the Ferris wheel?
Yes.
Okay, that means as I go up and down this Ferris wheel, I'm at the height twice, aren't I? I'm at the same height
Say that one more
twice.
time, Pete.
So if I'm at 20 on this Ferris wheel, 20 feet off the ground, I'm right here off the Ferris wheel, 20 feet off the ground at 17.5 seconds. But then I'm at 20 over here at 42.422 seconds. So it's clear I'm at 20 height on the way up of the Ferris wheel, and then 20 height on the way down.
Yes.
Okay, what if I asked you, Natalie, because you're going to have to do this by Friday. Natalie, I say, when am I 10 meters off the ground? And you don't use the graph, you got to use the formula. So here's the formula, right? Here's the formula. We have a nice formula. And I say, Natalie, when am I 10 meters off the ground? Where's height in this? Where's height in this? Where's height on this graph? Is it on the y-axis or on the x-axis? Where's height on the graph?
Y-axis?
Yeah, and the y-axis is this part over here, right?
Yes.
Okay, so whenever you see f of x, that's the old y. Y is equal. We just made f of x, but usually you'll see y. So that means if I want to figure out when I'm at 20, I would do this. 20 is equal to minus 15. And you got to treat cos, you got to treat cos of 6x as the last thing you solve. You solve the numbers first. What do? How do I get cos 6x all alone?
Okay, you're gonna subtract 16 from both sides.
Okay, and I get this.
Then you're gonna divide negative 15 both sides.
Yep. And I get this. Can you take 4 and divide it by negative 15 and tell me what you get? To 4 decimals.
Negative 0.2666.
0.266 repeated forever, right?
Yes.
So I got this. Now, it looks like my cos, before I solve 6x, which is a period transformation, it looks like my cos of this value, whatever that value is negative, isn't it?
Yes.
Can you tell me from CAST, where cos is negative?
In quadrant 2 and 3.
Yeah. Quadrant 2, which is the degrees 90 to 180. 90 to 180. And quadrant 3, which is degrees 180 to 270. Okay, fair enough. Now, before I can get inside the brackets, I have to get rid of that word cos. What's the opposite of cos?
Arccos.
Arccos, you got it. So I got arccos both sides. When I arccos the right side, that cos disappears. So I got an arccos negative 0.266666 is going to be equal to 6x because the cos disappears when I arccos. When I arccos the cos, that disappears. Okay, I just have to find the arccos of negative 0.2666. Can you take negative 0.26666 and then hit arccos and tell me what you get?
Yes. 105.466.
So you get 105.4666 is equal to 6x. Where is 105.466 in the Cartesian 360 degrees graph?
It's in quadrant 2.
Right. So it looks like our calculator spit out the first angle. Our calculator spit out this angle here. From here, from here all the way to here, which is an angle of 105.46, right?
Yes.
Okay. Now, before we solve the 6x, this is really important. What's the acute angle? If that's the terminal angle, what's the acute angle? The acute angle would be found here, by the way. The acute angle's found here.
Yes, 75.
Well, let's do it.
Something.
Let's do it accurately. Let's take our calculator and take 180 and subtract 105.4666. What do you get?
74.533.
74.533. Right?
Yes.
So that's that acute angle here, isn't it? Right there.
Yes.
Let's be nice to ourselves and we'll call it 74.5. Well, didn't we also say that the next cos curve that's negative falls in this quadrant?
Yes.
Okay. What is the acute angle if I put it on the other side? It's this, isn't it? If I do a different line that's blue, that goes, and it goes all the way here, and it has a little acute angle that's the same as this one, right here. My question is, what is the terminal angle? If I start here and go all the way to blue, what's the terminal angle?
That's going to be... Can I do my calculator?
Yeah, but what is it generally? What is it supposed to be? Like, what are you going to put in your calculator?
74.5 times 2.
No, you're finding this.
Plus 185.
You're finding this angle here. I don't want that angle. Let's forget about this first angle. Forget about this angle. I'm trying to find what is the angle all the way from the beginning.
Oh, 100. 180 plus 74 divided
Right.
by 5.
Tell me what that angle is.
254.5.
254.5. That means these are my two possible solutions for this question. So I'm going to do a 0.5 for this one to make it easier on myself. Why are there always two possible solutions? Because on my Ferris wheel, I hit that height on the way up and on the way down. On the way up, it's in quadrant 2. And on the way down, it's in quadrant 3. Because my Ferris wheel's going like that. Okay.
Wait.
Yeah, well, my brain. And that's before you do that, before you solve this part. Before, even if this had a 6x minus 30, like that,
Yeah.
you solve this angle thing before you solve the x transformations. You figure out the two angles before the x transformations. Say that again. You figure out the two angles before the x transformations. Okay, now I can just... I'll prove it to you in a second. Now just solve this one. Use your calculator. 6x is equal to 105.5. How do I solve for x?
You're gonna divide by 6 on both sides.
Yeah. So what is 105.5 divided by 6 according to your calculator?
$17.583.
Okay, 17.58 will do it. So that's a ton. Does my Ferris wheel go by in 60 seconds? Or whatever,
Yes.
whatever it was. I forget what we did by 360. Yeah, 60 seconds. So that means this isn't my x-axis time then, if my Ferris wheel goes around in seconds, isn't this time? So it looks like I hit at time 17.5 hit 8, I hit a height of 20. And then can you solve this one for me?
$42.41.
So time is equal to 42.1. I hit height of 20 seconds. So according to my calculation, I'm going to hit the height of 20 meters at 17.58 seconds on the way up and at 42.1 on the way down. Let's see if we are right. Let's find our Ferris wheel. That's not our Ferris wheel. Let's find our Ferris wheel. That's our Ferris wheel. Let's go look at, see what height. Look, 17.578 seconds, I hit a height of 20. And look, 42.422, I hit a height of 20. Why are there two solutions? Because cos can be negative in two quadrants.
Okay. But that would be the same with sine?
Yep. The only exception is the top of the Ferris wheel. There's just going to be one answer. So you have to remember that cos curves have only one max and two minimums. Or sorry, normally without the transformation, cos curves have two maxes and one minimum. But with the transformation, that changes. And sine curves have one max, one min, and three middle points. Every other point is 2. Why 3? Because they ended at 360, and 360 is the same as the beginning 0. That's why there's 3 for sine curve. But you can see, we can solve the 20 meters by putting it here for y and solving our numbers. And then before we solve the internal part, we have to figure out where the two angles are using the acute angle. Yes, what's your question?
So when we find the acute angle for the first one, do you just add that same acute angle to like?
So let's your calculator. Hang on. It's a good question. When we use our calculator, if it can fall in the first quadrant, our calculator will always give us the first quadrant. If it can fall in the second quadrant, I lost it. Hang on. Our calculator will give us the second quadrant first. So our calculator will either spit out the first quadrant or the second quadrant. Let's say our calculator spits out 120. What quadrant is that? And let's say that our thing can fall in quadrant 2 and 4.
That's quadrant 2.
Yeah, that's quadrant 2. So 120 is all the way from here to here. What's the acute angle?
60.
Yeah. Since the next one falls in quadrant 4, that's over here, and the acute angle's here. It's always between the line and the x-axis. But what is the terminal what is the terminal or principal angle if I go all the way around?
360 minus 60.
Which is?
300.
There. Then you solve the
We
internal.
always use the acute angle.
Yeah, you're always using cast. That's why they taught you cast.
Okay.
And if we're solving for sine, so let's look at cast. Okay. Here's how our calculators work. If sine, cos, or tan is positive, our calculators always spit out quadrant 1 because that's the first time they're all positive. Okay? If sine is positive, or is positive, the other quadrant is quadrant 2. If sine is negative, okay, now let's do it by sine, cos, cos, okay? If sine is positive, our calculator spits out quadrant 1. The other quadrant is 2, according to cast. If sine is negative, here's a good example. Where does sine first be negative? It's not in quadrant 1 because that's all positive. In quadrant 2, sine is positive. Right. Our calculator, if sine is negative, our calculator spits out quadrant 3 because that's the first time sine is negative. The other quadrant that sine is negative?
4.
Right. So that's the two areas we have to find. If cos is negative, where's the first time cos is negative? Which quadrant?
2.
Yeah. Our calculator will spit out quadrant 2. Where else is cos negative?
Quadrant 3.
Yeah. We use acute angles to find quadrant 3. And I should have written that up here. Use acute angle for the second one. The second quadrant. Use acute angle for the second one. Okay. Now finally, I didn't do cos is positive, which is weird. So if cos is positive, which quadrant will it first be positive in?
Quadrant 1.
We'll spit out quadrant 1. Yeah? Where else is cos positive?
Quadrant 4.
Is quadrant 4, so we have to use the acute angle to find that one. All right, finally tan. Where's tan first positive?
Quadrant 1.
Our calculator will spit out quadrant 1. Where else is it positive? We have to use our
Quadrant
acute
3.
angle to find quadrant 3. And you have to do it before all the x transformations. For instance, if we see this, cos 6 open brackets x plus 3 is equal to whatever, 33. And we solve, we do arc sine, and we get this. 6x is equal to an angle of, 45. This is it's cos, so we know it's cos. This is positive, so our answer is going to be in quadrant 1. It means our angle is 45, and to find the other cosangle, we have to take 360 minus 45, 315. Then we can solve these x transformations. So you have, before you ever solve the x transformations, you have to find the two angles using your knowledge of CAST. So that would be the two situations in this case, because our calculator spit out 45 for the first one, and since this is a cos, since we started with cos, we know that positive cos occurs in quadrant 1 and quadrant 4. So we have to take 360 and subtract. So essentially, here's the rule. Quadrant 2 is 180 minus the acute angle. Quadrant 3 is 180 plus the acute angle. And quadrant 4 is 360 minus the acute angle.
Okay.
That's a lot to absorb. That's all of the unit that's coming up, and it's one of the most important units in my opinion, because it's really important to solve y. It's very easy to solve x, because you just plug x into the right side of the equation. All right, Natalie, if you have any questions, shoot me an email. Just remember that last minute it's going to be harder for me to answer. And your test is on Friday?
Yeah.
So if you have any questions and you want to talk about something, you do what you normally do, which is shoot me a little text and I do a little video and send it back. Are those useful?
Yeah.